And in the previous lesson, we looked at covalent substances. And in today's lesson, we're going to look at a comparison of all the different types of bonding that we've seen, covalent, ionic, and metallic. And we're going to see how they're different, how they're the same, and what properties each of them has that make them useful. So you can see here, on the very left-hand side is something like a metallic bond. Lots of big nuclei sitting next to each other and something in between. Here we have to the right of that, we have a molecular substance. You can see the little ball and stick model. And here we have something that resembles an ionic substance, alternating blue and red. So we're going to see how each of those fits in this lesson. So first things first, metallic substances. So we form metallic substances by the attraction between the positive metal ions, so these guys, the nuclei, and the negatively charged delocalized electrons, which are these blue minus signs. The delocalized electrons give excellent electrical conductivity because they're free to move around all the way throughout the lattice. They have high melting and boiling points because the force of attraction is actually very, very large. So this attraction between the positive and negative charges has actually a very large value, and that means that melting and boiling point will be very high because it takes a lot of energy to separate all of those bonds. And it has an excellent thermal conductivity because each of those nuclei are very close together, so they can bump into each other and spread vibrations. And also the electrons, which can be excited by thermal energy, can actually go and strike other nuclei and make them vibrate also. So it helps to increase the thermal conductivity of that substance. So now ionic substances. It's formed when metal atoms donate their electrons to non-metal atom. So one forms a positive ion and the other forms a negative ion. As I said, positive and negative ions are formed, which are bonded together through electrostatic attraction. So this one is attracted to this one, and this one is also attracted to this one. And that's by the same kind of, it's analogous or very similar to the way north and south poles of a magnet are attracted to one another. Oppositely charged things attract one another. And that's what's happening here. The resulting substance is very hard and brittle because it's very hard because there's a very strong force of attraction, and it's brittle because certain defects can actually propagate through very quickly. They have very, very high melting and boiling points, and that's because of that very strong attraction, as I mentioned. That high boiling point and melting point is related to the very strong bonds between positive and negative charges. You'd be surprised by the fact that even though there's so much charge here, they're actually a poor conductor of electricity in solid state. In the solid crystal form, these ionic substances are very poor conductors. But if you can separate them, either as a molten or aqueous, in either molten or aqueous state, the substance can conduct electricity very well. So moving on to covalent molecular substances, formed through the sharing of electrons between atoms. So the covalent bond is formed by the sharing of electrons, resulting in an ensemble of discrete particles called molecules. We result in an ensemble of discrete elements or discrete things that we call molecules. So these guys are all called molecules. Covalent molecular substances have very low boiling and melting points because the attraction between these molecules is practically zero. Each of those is free to move around by themselves, so they can go bouncing around and being free. They have poor electrical conductivity and usually occur in gas phase. So the poor electrical conductivity comes from the fact that all of these are electrically neutral. So even if they are moving, there's no charge, so they don't really conduct electricity. And there are no free electrons because they're all locked up in these covalent bonds. The reason why they're gas is because the bonds between them are so weak, very little energy makes them go flying off in all different directions, which is exactly what a gas does. They act like gases when there's very little energy input. Okay? So we've talked about covalent molecular substances now. So we're going to talk about covalent network substances. This looks like a scary image, but really all it is just at each of the corners is a carbon atom. So just imagine there's lots and lots of carbons all stuck together. Covalent network substances are formed by the sharing of electrons. But instead of forming discrete molecules, like in the molecular case, atoms bond with adjacent atoms to form like a grid or a network. So each of these carbons bonds to all of its adjacent carbons to give a bit of a network structure rather than little molecules that are free to move by themselves. These substances have extremely high melting and boiling points, poor electrical conductivity. So the high melting point and boiling point comes because each of these bonds is very hard to break. And there's millions and millions of them. So in order to separate the elements in such a way that they're free to move, you would have to break thousands upon thousands of bonds, which are all quite strong. And again, like the molecular case, all of the electrons are all stuck in these bonds. So because they're all stuck in these bonds, they can't conduct electricity, so you don't have electrical conductivity. Generally, because of the way the bond structure works and the fact that they don't want to interact with other chemicals outside of their bonding, because all of their electrons shells are full, they're generally insoluble in water and many other solvents. Okay, so not many solvents can dissolve these covalent network substances. So that concludes today's lesson on a comparison of the different bonding types. We looked at metallic, covalent molecular, ionic, and covalent network substances and their properties and why those properties occur that way. So we'll move on to the question segment now, and hopefully you'll be able to utilize this knowledge to answer some questions.